Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors Chapter 8 Quiz Review Solutions on Sequences and Series. For this problem, I'm trying to find the 76th term of an arithmetic sequence. This is a sequence where all the terms have a common difference, so you just keep adding or subtracting the same thing over and over again to get subsequent terms. So to figure out the nth term, we're going to use the nth term formula for an arithmetic sequence. That's an equals a1 plus d times n minus 1. And for this one, we have an a1 value they gave us of negative 44. So that's the first term in the series if we were to write out the sequence here. And then for d, we have to do one term minus the term right before it. So negative 41 minus negative 44 or plus 44. That's going to come out to 3 for our common difference. So we're essentially adding 3 each time. And then the n value is just the 76 because that's the number of the term that we want. So we can write negative 44 plus 3 times 76 minus 1. And I'll go to the calculator for this. So plugging this in, I get 181. So that's my 76th term. For this next problem, they're asking for the sum of an arithmetic series, which is essentially just an arithmetic sequence, but the numbers are being added instead of listed out. So all the numbers in this series have a common difference that separates them. The key on all of these is to start with the formula for an arithmetic series. So that's going to be n times a1 plus an over 2. So essentially averaging the first and the last terms together and then multiplying by the number of terms. So in this case, they gave us just about everything we needed here. A1 they gave us was negative 65. An, that's just the nth term. We want the sum of the first 43 terms, and they gave us term number 43 right here. So an in this case is just 241. And then the number of terms is going to be 43. So plugging all that in, we have 43 times negative 65 plus 241 all over 2, and I'm going to use the calculator for this. And just to be on the safe side, I'm going to use alpha y equals to get my fancy fraction so I don't have to worry about PEMDAS. So that all comes out to 3,784. For this problem, we're trying to find the sum of this arithmetic series here. Now, I'm going to start with my arithmetic sum formula, n times a1 plus an over 2. The problem on this one is they didn't give us all the information we needed. They did give us the number of terms. It's 44 here. They did give us a1, the starting value, at 66, but they did not give us the nth term, the 44th term. We only have the first 3 terms. So to find that 44th term, we're going to use our nth term formula for an arithmetic series. That's this formula here, a1 plus d times n minus 1. We have an a1 value of 66. We have a common difference of 71 minus 66, so 5 for d. And the n that we're looking for is 44 in this case. We want the 44th term. So plugging all that in, let me use my calculator. And that all is going to come out to 281. All right, so the next thing I'm going to do is plug 44 in for n in the sum formula here, 66 for a1, and for an now I'm going to use this 281 that I just found. So plugging all that in, using my calculator again, all of this is going to come out to 7,634. For this one, we want the indicated term of the geometric sequence, the 18th term of this sequence. Geometric means that I keep multiplying by a common ratio over and over again to get the next number. So my general formula for the nth term is going to be an equals a1 times r to the n minus 1. So we're taking the first term and then multiplying by the common ratio n minus 1 times, because we've already used up the first term here. So my a1 is 20. For the common ratio, we're going to do a2 divided by a1, or really any term divided by the term right before it. So 4 over 20 in this case. That gives us a common ratio of 1/5. We're dividing by 5 or multiplying by 1/5 each time to get the next term. So then for my formula, I've got 20 times 1/5 to the 18 minus 1. And I'm definitely going to need the calculator for this. So to enter this in the calculator, I did 20 times, and then I did alpha y equals to get my fraction form. And you actually don't need a parentheses around a fraction if you format it like this to raise it to an exponent. You can put one in there, but the calculator will often get rid of it anyway. So pressing enter now, that gives us about 2.621 times 10 to the negative 11th. For this problem, we want the sum if possible. If it's infinite, we could write the first four terms, but it's not an infinite series. So let's talk a little bit about this sigma, just to review it. This is basically telling us to take all the integers from our lower limit, which is negative 2, to our upper limit, which is 2, plug all those integers one at a time into this function here, which we call the sum and then just add all those things together. So plugging in negative 2, I've got negative 8 times negative 2 inside the absolute value, so absolute value of 16. And now we're going to add to that negative 8 times negative 1, so absolute value of 8, plus negative 8 times 0, so that's just 0 inside absolute value, plus now we're going to do negative 8 times 1, so negative 8 inside there, and finally negative 8 times 2, this is the last number that we're going to plug in, so that's negative 16. Now we'll just go through and simplify all this. So we have essentially 2 16s, because this is going to be positive, so that's 32 plus another 16's worth with those 2 8s. That's a grand total of 48. On this problem, they want the sum from 0 to 47 of 2 times 3 to the k. Now there is a fast way to do this problem, but if you're not sure about a series, you can just start plugging in numbers and see what it looks like, see if there's a pattern. So if we plug 0 in for k, we've got 2 times 1 essentially, which is just 2. Then if we plug 1 in, we've got 2 times 3, which is 6. Plugging 2 in for k, that's 2 times 9, so that's going to be 18. And, I mean, there's a whole bunch of these terms, right? So we just keep doing this until we finally get 2 times 3 to the 47. So there's a faster way to do this one. This is actually a geometric series. This is a bunch of numbers being added together that have a common ratio. We're multiplying by 3 each time. So because this is geometric, we can use the finite geometric sum formula. This one right here, a1 times 1 minus r to the n over 1 minus r. Good one to have memorized. So now let's figure out what each of these items are. a1, that's the first term in the series. And we already wrote a few terms out, so we've got that right here. That's 2. And then for the r value, that's what we have to keep multiplying by each time to get the next term. So that's going to be 3, because 6 divided by 2 is 3. And then finally for n, that's the number of terms in the series. Now be careful, you can't just use the upper sum limit here to find what n is. Because, I mean, that 47 would be the number of terms if we were starting at 1. Counting from 1 to 47 is 47 numbers, but we're starting at 0. So this is actually 48 terms that are in the series. And a little trick you can do to figure out the number of terms is just do upper minus lower limit and then add 1 to that, and you'll always get the number of terms in a series in sigma form. Anyway, we've got 48 terms for this one for n. So plugging all that in, that's 2 times 1 minus 3 to the 48 over 1 minus 3. And now we have to use the calculator. So plugging all that in using my fancy fraction form, alpha y equals, I end up with about 7.977 times 10 to the 22nd. So there we have it. On this one, we're trying to express this series in sigma form. So the key to this is figuring out the commonality between all these. Now we've got 12, 24, 36. These are all multiples of 12. That's kind of the common tie between all of them. So writing out our sigma form, we need a sigma, and we're also going to need a formula. If these are all multiples of 12, then 12 times n would be something we could work with. And now we have to figure out the lower and upper limits of summation. So for the lower limit, 12 times what would give me my first term of 12? Well, 12 times 1. So we're going to let n equal 1 be our lower limit of summation. And now the upper limit, where we have to stop, we see there's a dot, dot, dot here. So that means this goes forever, and infinity is the upper limit. On this problem, we're trying to express this series using sigma notation. So the common tie on all of these is these are all powers of 2/3, right? This is 2/3 to the first, 2/3 to the second, 2/3 to the third, and so on and so forth. So writing out our sigma here, our formula then should be 2/3 raised to, well, let's just say the n power. So if we want to get 2/3 as our first term, that means our starting n value has to be 1. And then we want to make it all the way to 16 over 81. That's really 2/3 to the 4th power. So that means we have to go until 4 for our upper limit of summation. On this problem, we're trying to figure out if the series converges or diverges, and if it does converge, its sum. So this is a geometric series, which means we need to take a look at the A1 value and the R value. The A1 value, that's just the first term, that's the 50 there. For the R value, we need to take a term and divide it by the term before it. So for example, negative 25 over 50, which in this case is going to give us a common ratio in R value of negative 1/2. Since negative 1/2 in terms of absolute value is less than 1, and it has to be the absolute value version that's less than 1, because all negative numbers are less than 1 otherwise. Since its absolute value is less than 1, that means this series converges, which means we can actually go ahead and figure out the sum by using our formula, S equals A1 over 1 minus R. So this is the sum of an infinite geometric series, not a finite one. So now we have an A1 value of 50 up there. 1 minus the R value, negative 1/2, so we're really doing 1 plus 1/2 downstairs. So this is going to be 50 over 3/2. And if we same change flip this thing, we've got 2 times 50 over 3, which is going to be 100 over 3. For this problem, we're trying to figure out convergence and the sum, if possible, of this series. So first, let's look at the A1 value in case we do need the sum. That's just going to be the first term, 2/3. Now for the R value, we take a term and divide it by the term before it to get the common ratio. So negative 4/3 over 2/3. And these denominators of 3 are going to cancel. You're just going to end up with negative 4 over 2, which is just negative 2. Now the absolute value of negative 2 is not less than 1. In fact, it's greater than or equal to 1. So that means that this series diverges because your terms are not getting closer and closer to 0. They're getting further and further away from each other. So we don't actually have to find the sum if it diverges. For this problem, we want the common ratio of an infinite geometric series that has a sum of negative 21/5 and a first term, an A1 value of negative 3. So for these, you just have to set up the infinite sum formula, S equals A1 over 1 minus R, and then just plug in for S and A1 and solve for R. So we've got negative 21 over 5 equals negative 3 over 1 minus R. Cross multiplying, we're going to have, let's see here, I'm going to make this a positive 21 in the numerator just to make my life easier. So I'm going to have 21 minus 21R on the left side, and I'm going to do negative 5 here times negative 3. So that'll give me a positive 15 on the right. So that conveniently gets rid of those double negatives. Next, let's subtract 21. That'll give us negative 6 on the right side. And then negative 6 divided by negative 21, we could actually reduce that by 3s to 2/7 for our R value. And just as a sanity check, the R value, the absolute value of this R value is less than 1. So this all makes sense that this converges and even has a sum. For this problem, we're trying to write the first 4 terms in general term of a power series for this function, and also the interval of convergence. We're going to be writing a geometric series, so we're going to start by getting the A1 and the R values out of this. This is already in A1 over 1 minus R form, or at least you could think of it that way. So the A1 value is just whatever's in that numerator, which is 2. And then for the R value, it's whatever's being subtracted from 1 in the denominator. Since we have a plus 5x down here, that means our R value is actually negative 5x. So now to generate our series, we're going to start with the A1 value of 2, so f of x equals 2, and then some other stuff. To get the other stuff, we just keep multiplying by the common ratio of negative 5x. So 2 times negative 5x gives us negative 10x. And then multiply negative 5 by that, we've got positive 50x squared. Another negative 5x gives us negative 250x cubed. And then it's time for ... and the general term that we can use to generate all the terms of this. So your general term, just to review, is going to have some n's in it, because it's kind of the nth term of your summand if you were writing sigma form. And it's helpful to start by just imagining what you want your starting n value to be. I usually let my beginning n value be 0, and then I think, okay, to get this first term, what would I have to do with n to get this first term of n equals 0. So that's my starting point. You can have n be anything you want as long as it works consistently and lets you generate all the terms of the series. But 0 is usually a good bet. So to start off with here, I notice that I'm alternating between positives and negatives. So one thing I'm going to need in my general term is a -1. And I'm going to make this -1 to the n power. Because we have to keep multiplying by a -1 over and over again. I want to make it the n power because my n I said is usually 0 to start with. So if I have -1 to the 0, that's going to give me just a +1 out in front here, which is what I want. Next, I'm going to need this 2 that's in that initial term because that 2 gets carried through with all these other terms. We don't keep multiplying by 2. It's just a one-shot sort of deal, but it's there. So we don't need an exponent on it, but it's there. Next, we keep multiplying by 5 each time. Now, we don't have any 5s getting multiplied in that first term, so I'm going to make this 5 to the n. Because again, if my n value to begin with is 0, then that would just become a 1 here and not show up. Next, I have x's to worry about. Now, for the x's, I don't want those to show up in the first term either, so I'm going to make this also x to the n. So if I just test it out here to make sure I'm doing things correctly, plug in 0 for n, this becomes a 1, these two things become 1s, you're just stuck with 2 in the beginning. If you plug in 1 for n to get the next term, well, now you've got -2 times 5, so -10, x to the 1, so that works. And generally, if you're successful 2 terms in, you've probably got the right general form, but you could keep going. One other thing, don't forget this plus ... afterwards, because this is an infinite series. If you forget this plus ... you're saying it's a finite series, which does not necessarily represent this function here. All right, speaking of representing this function, it's only going to represent this function inside the interval of convergence. So let's go ahead and find that. To get that, we have to let our common ratio, the r value, the absolute value of the r value, I should say, be less than 1. So I'm going to do absolute value -5x less than 1, and now I just have to solve this inequality for x. So we're going to do -1 less than some stuff in the middle, less than +1. Now, if you have a negative inside an absolute value and it's being multiplied by everything, so that means you can just drop that negative when you take this outside the absolute value. So I'm going to write -1 less than just plain old 5x with no negative, less than 1. Notice again, I dropped that negative after I dropped the absolute value. Next, I'm going to divide everything by 5 to get x alone. So we've got -1/5 less than x less than 1/5. And there you have it. For this problem, we're trying to find the function of x represented by this geometric series. To do this, since it's a geometric series, we're going to put this in infinite sum form. But before we can do that, we need the a1 value and the r value. The a1 value, the initial term of the series, is just whatever you get when you plug in your lower limit of summation, 0 in this case, for all the n's. So if you have -1 to the 0, 9 to the 0, x to the 0, that's really just like saying 1 times 1 times 1, so that's just 1. For the r value, we're just looking at whatever is being multiplied by itself over and over again. There's actually 3 things here being multiplied by themselves, so we can put these all together and write -9x as the r value. And now let's use this formula, s equals a1 over 1 minus r. So we can just write then f of x equals 1 over 1 plus 9x.